Welcome students. Welcome again to my another new lecture. I am Muhammad Tanbir Ahmed, lecturer, Department of Civil Engineering, World University of Bangladesh. Outline of the lecture. In this lecture, we will discuss about ACI concrete mix design. There are various methods for concrete mix design, but in our country we normally use ACI concrete mix design. That means American Concrete Institute concrete mix design. And in this lecture, we will perform a mix design. Here, concrete is required for a reinforced concrete basement wall located below ground, and we have to design the mix proportion for this concrete. The job specifications are type of construction, reinforced concrete basement wall. Exposure is mild, that means it is below the ground, not exposed to freezing or high sulfate. Maximum aggregate size is 37.5 mm. Slump is 75 to 100 mm. The specified 28-day compressive strength is 24 megapascal and standard deviation is 2 megapascal. That means the design strength may vary 2 megapascal. The properties of the materials used in mix are given in this table. Here, bulk specific gravity for cement is 3.15, for fine aggregate 2.6, and that is for coarse aggregate is 2.7. Dry unit weight of coarse aggregate is 1600 kg per meter cube. Fineness modulus for fine aggregate is 2.8. Absorption capacity in percentage for fine aggregate 1.3 and coarse aggregate 1. Surface moisture percentage for fine aggregate 4.2 and for coarse aggregate 0.5. And with this information we have to perform the mix proportion for 1 meter cube of concrete. And these are the design steps, and using these steps we will design the mix proportion. First, we have to gather material information, then we have to select the workability, which is also known as slump, then we have to find water and air content, then water cement ratio, cement content, coarse aggregate, fine aggregate, moisture adjustment, and lastly we have to perform a trial mix to identify whether the design strength has achieved or not. And these are the material information which is given in question. You can see slide number 4 to see the information from question. Selection of slump. We have to select slump value from table 10.1, and table 10.1 belongs to recommended slumps for various types of construction. Here, these are the types of construction. These are slump value in millimeter and these are slump value in inch. In question, it has stated that the concrete will be used in basement construction. So we can say that this concrete will be used in substructure. And as this concrete will be used in substructure wall, so the recommended slump is 75 mm. Estimation of water and air content. As step 2, we have to calculate water and air content from table 10.2, and table 10.2 belongs to approximate mixing water and air content requirements for different slumps and nominal maximum sizes of aggregate. Here, these are the slump value and these are the nominal aggregate size, that means maximum aggregate size. This table is also divided into two parts. The first one is for non-air entrained concrete and the second one is for air entrained concrete. And in question it has stated that our concrete is air entrained concrete, so we will use this part. And in question it is also stated that the slump value is 75, which is very near to 80, so we will use this row. And as our maximum aggregate size is 37.5, so the water content required for this construction is 160 kg per meter cube. And as this is the air entrained concrete, so we have to calculate the entrapped air. And in question it has stated that the exposure is mild exposure, and using this exposure we can calculate the mild condition entrapped air is 2.5%. Selection of water cement ratio. To find the water cement ratio, first we have to calculate the average strength of concrete using this equation. Here average strength equal to design strength plus 1.33 into S, where a designed strength is 24 megapascal, which is given in quotient. Standard deviation S is 2 megapascal, it is also given in quotient. And finally we got the average strength 26.7 megapascal. We can also calculate average strength by this equation, and which is average strength equal to design strength plus 2.33 into S. Here a design strength is 24 and S is also 2. And finally we got the average strength using this equation is 25.2 megapascal. And the selected average strength will be the higher one, which is 26.7. And using this average strength, we have to select the water cement ratio from this table. And in this table, these are the compressive strength, these are the water cement ratio, and this is for non-air entrained concrete, and this is for air entrained concrete. As our concrete is air entrained concrete, so we will use this column. And the average strength is 26.7. Here the 26.7 is in between 30 and 25. So we have to interpolate between these two value 0.45 and 0.52. We obtained the water cement ratio as 0.5. Calculation of cement. In last slide we got water cement ratio as 0.5, and from this ratio we can calculate cement content, and cement content equal to water divided by 0.5. And water content is 160 kg per meter cube, which we have calculated in step 3. And this is the water cement ratio, and finally we got cement content as 320 kg per meter cube. Estimation of coarse aggregate content. We will calculate the coarse aggregate content from this table, and this table belongs to a volume of coarse aggregate per unit volume of concrete. These are the maximum aggregate size. This is in millimeter, this is in inch. These are the fineness modulus of sand, that means fineness modulus of fine aggregate. In quotient it is given that our maximum aggregate size is 37.5. So we will search in this row, and the fineness modulus for fine aggregate is given in 2.8. So we will search also in this column. So the dry roded volume or dry roded fraction will be 0.72. Here volume fraction on dry roded basis equal to 0.72 per meter cube. Weight of coarse aggregate oven dry basis will be this dry roded fraction into dry unit weight of coarse aggregate. In quotient it is given that the dry unit weight of coarse aggregate is 1600 kg per meter cube. So we got the weight of coarse aggregate oven dry basis equal to 1152 kg per meter cube. Then weight of coarse aggregate SSD basis, that means saturated surface dry basis, will be dry coarse aggregate into water absorption capacity. Here dry weight is 1152 and water absorption capacity is 1%. So finally we got weight of coarse aggregate saturated surface dry basis is 1163.5 kg per meter cube. Estimation of fine aggregate content. To calculate the fine aggregate content, first we have to know the unit weight of concrete, and using this table we can know the unit weight of concrete. Here these are the maximum aggregate size and these are the weight of concrete, and this is for non-air entrained concrete and this is for air entrained concrete. As our maximum aggregate size is 37.5, so we will search in this row, and as our concrete is air entrained concrete, so this is our specified weight of concrete. So we can write the unit weight of concrete is 2320 kg per meter cube. And we know the concrete is the sum of cement, fine aggregate, coarse aggregate and water. And as this is the total weight, so if we subtract water content, cement content and coarse aggregate content from this total weight, we can calculate the weight of sand, which is 676.5 kg per meter cube. Here we have summarized all the items we have calculated previous. The cement content we have calculated 320 kg per meter cube, sand content 676.5 kg per meter cube, and so on. And these are the quantity and items required for 1 meter cube of concrete construction. And using this content or weight, we can also calculate the mix ratio. That is the end of our today's lecture. Thank you everyone.